Hello and welcome everyone to today's LeetCode challenge. And this is our day 302. And today's LeetCode challenge is question number 2364. Count number of bad pairs. We have given a zero index array nums. A pair of indices I, j is a bad pair if I is less than j and j minus I is not equals to nums of j minus nums of I. So we have to return the total number of bad pairs in the given array. So let us take the example number 1 and find out how we can calculate the number of paired pairs in this. Uh, for this, if we start our I pointer from this and our j pointer from the next previous element till the last element. Basically, we can use two pointer approach here. The brute force approach to solve this is two pointers approach. And what could be the two pointer approach for this? Let us check. First, to this example, let us initialize a CNT which starts from 0, and let us start I from here, and for every I, this is I, and for every I let us assume j will starts from its next position. That means first j is here, and in every inner j loop we will check what is the difference between two indices, that is j minus I. This j minus I is 1, and now check what is nums of j minus nums of I. 1 minus 4, that means 1 difference between indices, that is not equals to 1 minus 4, that means minus 3. So we will increment our count by 1. This CNT is 1. Update our I, our j will now points to this, and the difference is now 2 minus 0, that means 2. If this 2 is not equals to 3 minus 4, that means minus 1. 2 is not equals to this minus 1. Yes, the condition is true. So let us again increment our CNT. So our CNT is now 2. J is now incremented and goes to this here. The difference between indices is 3 minus 0, that is 3. And if this 3 is not equals to nums of j, that means 3 minus 4, that is minus 1. Yes, update CNT. CNT is 3 here. Now the inner j loop is terminated because if we again increment our j, this will go out of the bound. So our I is now incremented and points to here, and for every I, our next j will start from I plus 1, so our j will now points to this. And for this j, The indices difference is 2 minus 1, that is 1. If this 1 is not equals to nums of j minus nums of I, that means 3 minus 2 is 3 minus 1 is 2. Yes, the condition is true, so this will increase our CNT. J is now points to this position. This is 3 minus 2, that means 2, and this is 3 minus 1, that means 2. So here the condition is not true. 2 is not equals to true. This condition is not true in AF. So now we will not increment our CNT, and our inner loop is now terminated because again incrementing j will go out of the bound of this index. So our I is incremented, and now I will points to the next indices, that means here, and our j will start from its next here, and this will check 3 minus 2, that means 1. If this 1 is not equals to this 3 minus 3, that is 0. Yes, this 1 is not equals to 0, so CNT will increase to 5, and this will move to next index, and the condition is false for inner loop, so the inner j loop will terminated, and our I will not increment it further because according to condition we have to make sure that I is always less than j. So if we move our I here, we will not have any next place for j, because we will have to make our j pointer to immediate next element of I. So both loops are terminated, and this will return 5 as the answer to caller. But according to question, we have given the nums of length equals to 10 to the power 5, and in this brute force approach we are using two loops, so this will goes to up to 10 to the power 10 in worst case, and this will surely give us a TLE because we have to write a solution that can do computations better than 10 to the power 8 computations in 1 second. So what could be the better solution for this? The optimized solution for this is to make use of a dictionary or a map in this. So what could be the code for that? Uh, First we have counted the total pairs that can be formed from any input array. Let us count the total input let us count the total pairs that can be formed from any input array. Uh, if this is I, this is a pair 1, this is a pair, this is a pair 3. Now if this is I, this is a pair, that is 4, this is a pair, that is 5, and if this is I, this is a pair, that is 6. So we actually finds that for every input array that has size n, the possible pairs could be n into n minus 1 by 2, as shown here above. We can check for this. The input size of this is 4, so the possible pairs would be 4 into 4 minus 1, that is 3 by 2. So this will give us 6 as answer, 2 into 3, and we can check that we also checked through visualization that total possible pairs are 6. So first we take total pairs that can be possible, and then we initialize a good pair variable from 0. That means we were checking the total possible good pairs in this, and then a dictionary. So dictionary will looks like this. Let us assume this is an empty dictionary initially. For every I num I comma num in enumerate nums, that means for every I means this is index and this is num number for that index, and the difference is calculated. This time difference is num minus I, that means 4 minus 0. So for first iteration, let us assume this difference is num minus I, that means 4. This is 4, and we will check if difference in frequency. No, this is a frequency dictionary, and we will check that 4 is not present in dictionary. So we will initialize our dictionary of 4 with 1. That means we have a key 4 and that has a frequency of 1, and our I is again incremented and goes to this indices. Let us erase the previous ones, and this time this will check that difference is nums of num minus I, that means 1 minus 1, that is 0. This will again check if this 0 is in this frequency. No, 0 is not present, so put that 0 with frequency of 1 in frequency dictionary, and again I will now points to this, and this will check that if 3 is present to 3 minus 2 is what, that is 1, and this will check if this one is present in frequency or not. No, one is not present in this, so let us put 1 in this by 1, and now I goes here, and this will check 3 minus 3, that is 0. So this difference is this time is 0, and this will check if difference is in frequency or not. Yes, frequency dictionary will contain a key that is 0, so good pairs will be good pairs plus frequency of difference. That means 0, the previous value of good pairs is 0, plus frequency of difference, that is 1. This means good pairs are now 1, and again our I will not further incremented because that will go outside the bound of the input array. So good pairs are now 1, and finally we will return total pairs minus good pairs. That means total pairs could possible for this is 6, and 6 minus 1, that is 5. So we will return 5 for this to the caller. This is a very simple approach in which we reduce the time complexity from big O of n squared to big O of n into searching of this, that is log n. So the time complexity for this solution is, for in worst case, will be big O of n log n. This will search our key in log n time, and this is this will return our total bad pairs, that is total pairs minus good pairs. So instead of finding total bad pairs, we were finding what could be the good pairs in this. So let us code this, and let us first now this total pairs like this, and good pairs will be 0. Let us initialize a map named frequency and traverse on the input. Input array. Check what could be the difference possible and check if this difference is present in the frequency map. If it is, let us update our good pairs with and update our frequency of difference from its previous value plus 1, and if not, let us initialize our frequency of difference in map, and now let us return total minus good pairs. Let us run this and check if it is running fine or not. It is running fine, so let us submit this. So this will conclude our today's LeetCode video, and thank you so much guys for seeing this, and if you understand this video, please do like and subscribe to our channel. Thank you.